Accelerated curing tank testing of concrete cubes is a method used to quickly assess the strength and durability of concrete by simulating long-term curing conditions in a short period. So this is the acceleration curing tank in which we are going to pour the water into it so here you can see the water is going to be poured into the accelerated curing tank for understanding accelerated curing tank testing. So what is the solution accelerated curing tank will be testing? Accelerated curing tank testing is a laboratory technique used to test the strength and durability of concrete cubes. It involves immersing concrete cubes in a controlled water bath at elevated temperatures to accelerate the curing purpose. So the purpose of accelerated curing tank testing is followed in two steps, that is to predict long-term strength and evaluate the durability. To predict the long-term strength, that is to estimate the 28-day strength of concrete within a shorter time frame, that is 24 hours. So you can now see here the temperature is going to be set at 100 degrees Celsius. So slowly the temperature is going to be rise up to 100 degrees Celsius. And next the procedure which involves, so you can see here slowly the temperature is gradually increasing 32 like that. And the procedure involves preparing concrete cubes, casting and curing of concrete cubes according to standard procedures, accelerated curing. So you can see here so this is the M30 mixed design of concrete. We are going to test the accelerated curing, the strength and durability. So the temperature is going to be increased gradually up to 100 degrees Celsius to know the strength and durability of the concrete cubes of standard materials. So preparing concrete cubes. So this is the concrete cubes, casting and curing of concrete cubes. After casting of concrete cubes, these cubes are going to be placed on a vibrator, and after that they are going to be placed in accelerated curing tank. So the three cubes are going to be placed in accelerated curing tank. So now you can see the temperature is raised up to 100 degrees Celsius, that is 99. So now we are going to keep the standard cubes at temperature 100 degrees Celsius of 3 testing cubes of M30 mixed design of concrete. So now you can see this slowly the cubes have been kept in the accelerated curing tank at about 3 and half an hour. After that they are going to be removed, and after that they are going to be placed at 1 hour in normal cold water. And here accelerated curing, immersing the cubes in a controlled water bath at elevated temperatures about 100 degrees Celsius for a specified period, that is 3 and half an hour. Testing includes conducting compressive tests on the accelerated cubes. So the benefits which will include for accelerated curing tank will be time saving, quickly accessing concrete strength and durability, cost effective, reducing the need for prolonged testing periods, improved quality control, enabling the early detection of potential issues with concrete quality. So accelerated curing tank testing is a valuable technique for rapidly accessing the strength and durability of concrete. By simulating the long-term curing conditions, it provides valuable insights into the performance of concrete, enabling faster decision making and improved quality control. So now you can see after 3.5 an hour, the concrete cubes are going to be removed from the accelerated curing tank, and after removing these concrete cubes are going to be placed in a normal cold water at about 1 hour. So the accelerated curing tank is testing a valuable technique for rapidly accessing the strength and durability of concrete by simulating long-term curing conditions. It provides valuable insights to the performance of concrete, enabling faster decision making and improved quality control. So to know the accelerated curing tank testing, we should follow the standard procedures for more testing of these standard cubes for accelerated curing tank. So after removing from the accelerated curing tanks of these three standard cubes, they are going to be placed under normal cold water at about 1 hour, and after that we are going to test the compressive strength of these standard cubes. So the key considerations will be temperature control, ensure the water bath temperature is accurately controlled, timing, follow the specified curing and testing schedule, equipment calibration, ensure the testing equipment is calibrated and functioning correctly. So here the testing procedures involves preparing concrete cubes of standard size 150 into 150 into 150, initial curing, cure the cubes in a controlled environment before 24 hours. So after 24 hours they are going to be kept in accelerated curing tank, and cooling, the cubes have been removed from the water bath, allow them to cool to room temperature. And now you can see the concrete cubes are going to be placed in a normal curing tank to know the compressive strength of the concrete after removing these cubes from the curing tank at about 1 hour. And the compressive testing of these cubes for compressive strength using a compression testing machine. So the data analysis should be recorded and analyze the test results to estimate the 28-day strength of the concrete. So this is how we are going to know the procedure for accelerated curing tank. So here, after removing from the normal curing tank, the cubes are demolded. You can see here they are demolded, and they are going to, after maintaining at room temperature, they are going to test for compressive strength. So before going to test the compressive strength, we need to prepare the testing machine, ensure the compressive testing machine is calibrated and functioning correctly. We need to place the position of the concrete cube in the testing machine and ensuring proper alignment. So after that we should apply the compressive load to the cube until failure occurs. So after that we record results, note the maximum load at failure and calculate the compressive strength. And we should calculate the compressive strength by using the formula, that is compressive strength equal to maximum load by maximum cross-sectional area. So this is how these are the standard cubes. They are going to test for the compressive in the compressive testing machine, and after that slowly the load is going to be applied, and after the maximum load at which the cube will take place, by knowing the maximum load we are going to calculate the compressive strength of the standard cubes. So by using the compressive strength formula is compressive strength divided by maximum load, compressive strength equal to maximum load divided by cross-sectional area. So the compressive strength is, you can see here the failure crack patterns after taking the maximum load of these standard cubes in compressive testing machine. Similarly, the first cube taken the maximum load, that is 400 kilonewton, that is the failure patterns and ultimate failure, that is 400 kilonewton. And next, this is the second cube we are going to be placed in compressive testing machine. So you can see here the maximum load that is going to be carried by the second standard cube. So you can see it is crossing under 250 in here, under 300, 390, 400, so 410, so 430. So this is the maximum load taken by the second cube, that is 430 kilonewton. Similarly, by placing the third cube, gradually we are applying the load that is compressive in the compressive testing machine, the maximum load at failure, and next we are going to calculate the load in kilonewton. So this is how the load is gradually increasing at ultimate failure. So now you can see after 0 the load is gradually increasing for the third standard cube up to 250, 300, so up to 390 and 400, so up to 430. So this is also 440. The maximum load taken by this third standard cube is 430 kilonewton. So you can see the concrete is deteriorating by visualizing the cracks and patches are going to be broken off.
Plus
Next, this is the
430
calculation part, that is compressive strength
equal to V
is
divided by
Next, we are going to calculate 400, 430,
That
400 divided by 3, and after that we are going to
18.81
calculate the strength by
18.81
maximum load divided by cross sectional area,
18.81
and we are getting the strength as
formula
so you can see
1.64
30.
plus 8.09.
You can see the 39.74 MPa, that is
09.
Newton per mm square. So this is the average compressed strength of the standard
1.64
cubes
plus
after doing the
8.09,
cubes cured in
38.9.
accelerated curing time. Method is valuable